Alright, and recording. Alright folks, Almanzo here again. Okay, so in the last video what I did is I drilled the 7/16 diameter hole through this piece. Of course I drilled a pilot hole, then a 7/16 hole. So now I have this. So I have a 7/16 diameter ID and a 750 OD. Okay, so what I'm doing here is I'm now using a ball end mill to make the cup so that now it will be a ball and socket joint. Okay, so what I have to do is basically I need a fixed point, which in this case is going to be the face of my 3-jaw chuck. What I've done is I've used a piece of 125 keyway stock. It doesn't matter what it is, it just has to be rigid and of a known, it's so when you put everything in there, everything ends up exactly where you want it to be. This is the point in the process where the machining has to get very precise. Someone once told me that to be a good machinist has the precision of a surgeon and the patience of a saint. That will be tested during doing these parts. So here we go. So what I did is I already know that the ball the topmost piece of the ball needs to stick out 100 thousandths from this surface. So what I did is I adjusted the tail stock. Basically, I put my keyway stock in. I put the ball end mill. I extended the ball end mill to what I knew would be my end point on here. So I extended this tail, this drill chuck. I extended this until it just touched this piece, which would be the, of course, the face of this one. So I did that. I then backed it off 100 thousandths of an inch and then again inserted it until it just moved it forward until it just hit this piece. That made the ball position inside the part exactly where it needs to be so that I will have the ball sticking out 100 thousandths. So of course then I locked it all down. So enough of my babbling. So 7/16 hole, so the key stock goes in here. This is kind of hard to do because the camera's right on top of me here. I'm doing this on an iPad, and so I don't have a zoom feature on this. So anyhow, I go in here, make sure there's no swarf in there between my key stock and the face of the chuck. I snug it up a little bit. Okay, then I remove the key stock. Now I know that that front face is indexed exactly where it's supposed to be. And I tighten it down. I'm currently running this at 300 RPMs. I might want to note here, I do want to note, you want to use a longer ball end mill than what I'm using. This one's been heavily modified. It's been ground down when I did the first batch many years ago because it's not long enough to properly eject the swarf out of here for the depth I need to go. So you'll see me go in, have to pull it back out, get the swarf out of there, so on and so forth. I would recommend you go with a longer than standard ball end mill. So a little bit of machining oil on there, cutting fluid, and here we go. You'll see that the cuttings are ejecting now really well. But then as I get towards the end of the ball end mill, it will no longer do that. You can hear it start to squeal. Pull this out. Come off of there and go in again. I said, longer ball end mill would make this process a whole lot simpler. And I'm right near the end, and sorry, I gotta get in the way here. There we go. That's it. Okay, now remove the part. Okay, and oops, over, there we go. And now this will drop down in there. There we go. And there we go. We have our 100,000th reveal for the ball. And it swivels around nice. And the internal finish is also very nice. It's not a deal breaker if the internal finish is not perfectly smooth, but you want to try to eliminate the chatter as much as possible. Now you'll see that this ball actually goes in here quite readily. These balls, remember, these are half-inch diameter balls. Half-inch diameter ball into a half-inch hole does not, there's no clearance. As you'll see here, this one is half-inch, and it goes in there quite hard. That's because these balls need to be sanded at a later point. They need to be sanded down 1/1000th or 2 to get them down closer to like 0.498, 497, because you need that clearance to get this to operate correctly. So that's it for that so far. Okay. I actually upgraded my light. I was using a halogen light, 60 watt. This is an LED, 15 watts, and it doesn't heat the parts up. The problem with the halogen is that it uses a lot of electricity, and the radiant energy from it will heat the chuck up, and you know. So yeah, I finally went with a LED spotlight, 1400 lumen, 5000K, the daylight, and yeah, you can see it. It really makes a vast improvement. So, okay, and there's that. And I've got some over here that I've already started. These ones are already done. And so yeah, the work continues. And yeah, so far I've been able to do about 12 an hour. So it's going to take me a while. Alright, that's about it. Hope you enjoyed the video and it was informative. Alright, bye for now.